Okay, now we're going to take a look at quadratics that are in different form. They're called vertex form. It has to do with the vertex, location of the vertex. And if you take a look at this graph, you can see where the vertex is, and that's our minimum point, and that's at -3 and -3. The problem with this graph is it's very difficult to see where the x-intercepts are, and it's very difficult to identify those. Now, if I tick on Desmos, it will give them to me, but they're not whole numbers, and they're very difficult to actually find. So when we get graphs like this, sometimes it's much easier to deal with the graph in vertex form. And if you take a look up here, this graph is in vertex form. Y is equal to, and then in brackets, x plus a all squared plus b. Now let's just take a look at what these letters, if they're numbers, what they do to the graph. So let's just move a around. Now you can see what's happening here. As I move A, the graph, and in particular the vertex, is sliding right and left. So that's what A actually does to the graph. That, whatever that value of A is, if it's, now take a look, if it's 2, look where the graph and the position of the vertex is. If it's 3, look where the graph and the vertex is. So when A is 3, the vertex has moved to the left as opposed to the right. When A is, say, -4, the graph has moved 4 units to the right. So the value of A is basically the opposite of the actual move. Opposite. So if we write this down, this position of the vertex here on the graph, basically it's been moved to the right 4. So in the equation, it's actually written as the opposite. So for this A, it's always the opposite in the equation to what's actually going on with the graph. Now let's take a look at what B does. So if I just, I'll just move this to 2. Now let's move B. So B is this part up plus B, and look what happens when we move B. Slides the graph, or moves the vertex more accurately, basically. The graph doesn't change size or shape, it just slides. It slides along. The vertex is sliding up and down. Now let's take a look. If I go to 2, the vertex has moved up 2. If I go to -4, it's gone down 4. So the fact that it's done that means that basically this move is the same as what goes into the equation. So let's just move this thing. Let's just move it here. Let's just move it here. So the equation of this graph, the vertex is at a position, it's been moved over 2 and up 3. So if we were to write the equation, we know that A moves the graph right or left, and it's always opposite. So it's moved 2 to the right. We would write that as -2. It's always opposite, and that's where a square comes in. And then we've moved it up 3. Up 3 in a quadratic, when you move the vertex up 3, it just is exactly as it is. So up 3 is +3, down 3 is -3. So that's what we have in vertex form. So you're going to play around with this with the assessment. You can move the points around to various locations if you wish, but you can see that moving A moves the graph right and left, moving the B moves it up and down, and A is always opposite. So we can move the graph this way, and we can move the graph that way, we can move the graph up, and we can move the graph down.